Here you go, building a battery pack using Samsung 40T lithium ion 21700 cells. Total of 48. I will be building 16S 3P for my electric scooter. I will show you step by step how to put these batteries together, how to connect them together, every step. Step 2, got the batteries joined together in a series in a row of 16 each, total of three rows, 48 cells. They're combined with packing tape, a simple packing tape that you use to pack your boxes up for shipping. That's all it takes. Taped one side, the other side nice and tight. Repeat the steps for the second row and third row, same way. See that? Join them together. Like this. And then what you do, you just pack tape around the whole battery pack. It's on the side, all around, couple layers. It'll be nice and firm because this is not the first time building it this way. I've done it, I've tested it with Chinese battery cells, 18650s, and it worked out well. This is my second build for Samsung 40T 21700 cells. They are high discharge, 30 amp continuous discharge, high performance battery cells. And the next step will be using silver paste epoxy, which is I don't know where it's at, somewhere. Be using silver paste epoxy 8331D from MG Chemicals. It's a high grade silver content, 2-part epoxy. One is silver and the other part is conductive epoxy. This works well. I have already tested it with Chinese battery packs, Chinese battery cells, and the conductivity is perfect. It's very good. Alright, I will show you the next step. Here you go, chaps. To connect the batteries together, I'll be using copper plate, 99.9% pure copper plate, 1 millimeter thick. They come in pair. I bought 3 of those, so that's total of 6. 1, 2, 3, 4, 5, 6. 6 of these. These are solid copper plate. I'll be placing them on the battery cells in parallel groups. One on the negative terminal, positive terminal here. One goes there. Like this. It will stick out. The copper will stick out. It will overlap. But that's okay. If you want to cut it, you can, but I'm not going to do it. It will maximize the contact point and the size of conductivity, the size of the metal for conductivity, to handle the current and to keep the temperature down, to prevent temperature rising. These will go to pair like this. perfect length, almost perfect size. I cut into threes. I can make 3 connections per bar, about 5 centimeters here, 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 total of 15 centimeters in length. These are 21 millimeters width because they're 21700 cells. So this will work out. All I need is 6 of those in order to connect 3P battery pack, 3 parallel. Alright, next I will show you applying silver paste epoxy to attach this on the battery cells. Alright. Okay guys, ready to apply silver paste epoxy on my battery cells to attach this copper plate, 1 millimeter thick copper plate. By the way, these are just the films, protective films on both sides. These are full copper. Before applying this, people make sure that people understand, for the newcomers, for the people that are planning on building their battery pack, for those who are ready to build for the first time, make sure that you understand the battery arrangement correctly. In a typical battery pack like this, you have one line, a single column of each terminal. The positive terminal here, one line of positive terminal, one line of negative terminal. And this is where you'll be connecting your metal connector here and attach your wires, your charging wires, your charging wire, negative charging wire and negative discharge wire. And you will want to separate them, not join them together. You don't want to use, although it will work, using the same wire and share it, split to charge and to discharge, your voltage reading is not going to be accurate. It's going to show the voltage closer to the charging voltage and not the actual charge of your battery pack. There are differences. So you will want to separate them, preferably separate them as far as you can. Like discharge wire here, charge wire maybe here on the metal. And the inner connecting groups are in pairs. So the inner ones, you have a negative here, negative end, positive end, negative end, positive, negative, positive, negative, positive, negative, positive, negative, all the way to here. You will need to connect these two together, connect in pairs. Like this. Okay? Like this, like this, like this, like this, except for the ends. That will be my top side. You can make this bottom side if you want, it doesn't matter. I prefer this way because with 16S in series, the even number connection will give you terminal ends on the same side, positive and negative end on the same side. It's easier access. You don't have to, it's not on the other side. However, if you have an odd number series connection, for example, if you make 15S or 17S battery, then you will have a positive end on one end, one side, negative end on the other side, the bottom side. I prefer the even number. I will explain more detail on the voltage later. And this is my top side. Or you can make this bottom side when you build your battery pack. It doesn't matter. I prefer to do the connection the bottom side first. So I will make this the bottom side. Okay? And down here will be my top side. So for the bottom side, you need to connect all cells in pairs using your metal connector, starting from the first all the way to the end. Pairs, 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 all the way up to here. That is my bottom side. And then once that is done, once it's dried, then I will flip over, work on the top side, leave the positive end untouched, negative end untouched, connect these in pairs on the inner groups of cells, in pairs, except for the positive and negative end. And I will attach these on the negative end and positive end by themselves, and you'll be attaching your wires, your charging wire and discharge wire, and you will want to separate them, not join them together. You can use the same wire and split to charge and or discharge, but I don't recommend it that way, because if you do that, your voltage reading is not going to be accurate while you are charging, because your voltage reading will show closer to the charging voltage, not the actual charge of the battery pack. There are differences, which is why you want to separate them far as you can, and not instead of joining them together. So you have a charging wire over here and discharge wire over here, preferably. Okay, I'm going to start now. Okay, applied silver epoxy, starting with this pair here, positive and negative. Just apply enough to make good contact. Don't apply too much, don't apply too little, because then it will reduce bonding strength. Here's your metal plate, copper plate. Apply here. This will be perfect, like this. Press it down a little bit. No, don't press it too hard. You don't want to squeeze it. You don't want to squeeze the silver paste out. This is perfect. This is how you do it. And it takes 20 minutes to cure. 20 minutes to dry, and several hours to cure, about 3-4 hours to be safe. I'll be repeating the step all the way to the end for this side. Pairs, 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 pairs. Okay, the copper plate has been applied on one side, which is my bottom side here, as you can see. Applied with silver paste epoxy, and they're drying. They're all connected in pairs. Pair groups, parallel groups. It's very simple, as you can see. One end is very simple, and the other end, which will be my top side, you will have its own positive terminal and negative terminal separated. They're not connected to their neighboring cells. Only the inner groups of cells on the top side here will be paired together, connected in pairs. When working on batteries, make sure that for safety precaution, be careful not to hold any metal pieces or have any metal pieces on your skin, like if you're wearing a ring or watch or anything like that, or even holding screwdriver. And especially don't hold wires, loose wires hanging or dangling around, because it can easily touch where they should not be touched on the battery cells and will cause short circuit. They don't always damage or destroy the batteries, but they can hurt depending on how bad it is, where you touch them. And it can get very dangerous because some metals that have a high resistance, and it's a small mass of metal, then it's enough to cause spark and catch fire, even burn up, disappear on you. But if the metal piece you're holding is very conductive and solid, probably nothing will happen. Even if you are short-circuiting it, you won't notice you are short-circuiting it. That's the thing. So you gotta be very careful. Don't have any metal piece on your hands when you're working on this. And make sure that your hand is dry, not wet hand. If your hand gets wet very easily, you'll want to put gloves on and work on these. And make sure that try not to put have oil on the cells from your bodily fluid, your oil on your skin, because that will interfere with bonding strength and conductivity, especially the bonding strength for the silver paste epoxy. It's drying now. I'm going to give it probably 3 hours to cure it, and then I will flip to the other side and work on here. All right. Okay guys, this is the top side where negative and positive terminal are facing, and it is done. Apply the copper plate on all cell groups with the wires. Wire the thick 12 gauge copper wire, 99.9% copper wire, and the charging wire, which is 20 gauge, have been silver paste epoxy. There's no soldering because I don't have solder. This is the negative end here. As I said before, that's the positive end, positive terminal, top side. I'm waiting to let it dry. I'm gonna let it cure overnight. It's getting dark outside, and I have already checked the voltage, and it is showing that all batteries are connected. It's showing 54.6 volt, but that's because each battery cell, when I checked the voltage, every cells were charged at 3.42 volt, and that gives you 54.6. Everything seems to be good. I'm gonna let it dry, and then I'm going to charge it tomorrow. I'll also try testing it on the scooter, see if it works. Yep, this is it. And when you do this, make sure that you don't accidentally touch from this metal piece to the neighboring group cells. Do not touch any one of these. They must be separated. If they touch, you will short circuit them. Same thing with the bottom side. No problem with your own hands when you touch them. Be free. Don't be afraid touching it. You're not gonna get zapped. You're not gonna get electrocuted. You're not gonna damage the batteries with your hands because they are not conductive. Even though your body carries some level of electricity, which is very small, but it's not a conductor. Your skin works like an insulator, just like an insulator for your wires. So don't worry. Just make sure you don't carry any metal pieces when doing this. Alright, I will tomorrow I would check the I would do the charge and running the scooter. Wires have been installed on the battery, negative and positive discharge and charge wires. They're all tucked down using secured with packing tape. And make sure that they are tucked down good, like that, bare wires, so you can easily bend and tape them. And you can always cover them with tape or and seal them with silicone, whichever method you prefer to make it waterproof and contact proof. And the wires, make sure that when you install your wires one at a time, make sure to cover the end with what do you call this thing? This doohickey thing, what is it called? Heat shrink. It will make it as like a protective wall so that you don't accidentally touch with other metal parts. You don't want to short circuit them. Do that on each wires. And then when you are ready to install it in the scooter deck, then you can either connect one wire at a time and remove this, or you can just try to press the wire in from the other end with the heat shrink and then heat shrink them. Same thing with the charge wires. Look what we have here. My 48 volt single motor rear drive electric scooter. Let's see what's under the hood. As you can see, that's my Samsung 40T 21700 battery pack that I built. Has been installed. As you can see, the copper plates there. Samsung 40T. In the configuration of 16S3P, totaling 48 cells. Installed, wired up, and I have been using it, testing it for 2 weeks. I've been going out there riding my scooter, go to the grocery store, pick up packages, go get jugs of water. I did put some load test on the scooter by putting heavier weight on it. Good news is it's working. Battery cells are working without failure. There's no catastrophic failure, no problem with charging and discharging. It's charging right now, and I'm gonna unplug. It's being charged up by my solar panel through the charge controller. That's how my shed is set up. Unplug. It's not fully charged yet. Just to show you what the voltage is. What used to be a 48 volt scooter is now at 72.9 volt currently. It goes all the way up to 74 volt at full charge, because each cell capacity is at 4.6 plus volt, not 4.2 volt. It does not have a BMS. It's just raw battery power, and you don't need BMS. They do not work as the way you believe or the way you assume they work. They do not work. It's flawed. I will explain more detail about that in a separate video, 45 minutes to an hour session just for that. why you don't need it. Because one thing, I have also tested the battery pack, they self-balance each other when they're connected in series and parallel, which is 16S3P. They self-balance across the entire battery cells, across the entire battery pack. Both the parallel connections and series, they all get self-balanced. I tested the voltage by disassembling the Chinese cells that I was testing with without the BMS, and they get self-balanced as what God told me they will get self-balanced. Anyway, here's the power. That's a lot of voltage. It works. The disadvantage is it cuts power easily under load. When I try to take off from standstill, applying medium level of throttle, maybe even a little less, it's enough to, because of a voltage spike, it dips all the way down from 70 plus volt to 40 volt or below, triggers the controller activating the low voltage cutoff, and it cuts power. By the way, this is a 3-mode voltage controller, supports both, I don't know if you can see it, it's 48 volt, 60 volt and 72 volt. And the lowest voltage that it will tolerate accept is 40 volt. Voltage spike, voltage drop more than 20 volt, maybe 22, 23 volt voltage drop under load when you apply pressure, when you apply throttle. So it cuts off power, but the good thing is it'll give you power right back as long as the voltage, because the voltage will rise back up. Whenever it hits that low voltage, the controller will just cut off temporarily in a split second and your power is back up. You just gotta modulate the throttle a little more carefully, apply more carefully so that you don't hit that low voltage cutoff again, so you can ride your scooter. That's what I've been doing with this. And I have been able to ride it. You actually use my scooter as a transportation. Range is cut significantly because of voltage spike, but I'm able to ride it, go to grocery store and whatnot. And I have to keep the speed setting gear 1, not gear 2 and 3. Gear 2 and 3 is too much. It draws too much power. Gear 1 is much less sensitive, easier on the throttle, and it almost prevents power cutting off again because the voltage won't drop as much. Just gotta take off carefully, and once scooter has picked up speed, start moving and cruising, then the voltage will become more stabilized, and it's easier to apply throttle, and I can go faster and faster. I can go about 30 miles per hour with this battery configuration. With gear 1 setting, which is eco, which is pretty good. That's pretty dang fast for gear 1. Just imagine what it would do at gear 2 and 3. By the way, that's 50 amp sine wave controller. The battery problem is, I've found out that battery pack in 3P parallel connection is not enough. to handle the power, to deal with the physics, the weight of the scooter and the weight of the scooter rider. Even though I'm fairly light, it's having struggles. If you are a heavy person like weighs 250 pounds or more, forget about it. Don't even bother building a 3P battery pack. If you are going to, just use it for your home power bank source, your home battery pack. That will be fine, but not for scooter. 3P is just not enough. That's what I wanted to show you all. Good thing is it works. Just the battery pack is small. You need at least, with bare minimum, 5P or 6P. Higher the better. I was disappointed in a way because I was shocked actually. I would have thought that these battery cells would be able to handle it even with the fewer number of cells, because each cell is a very high performance, high discharge, 30 amp continuous discharge rated, which will actually give you power of 45 to 50 amp per cell if you draw it, if you have enough power on the controller. And it's 4 amp hour cells. So 4 amp hour times 3 parallel gives you 12 amp hours. It's a 12 amp hour battery pack. And apparently that is just not enough. You need to go higher number of parallel connections. No wonder the battery pack assembly, the manufacturers, the suppliers that build battery packs, that they go at least 8P, at the bare minimum 7P or higher, in some case 9P. Because I opened them up. I opened up other Chinese battery packs in the past, the scooters that I had owned. And even those small battery size battery packs, like a 20 amp hours, 23 amp hours, they are 2500 milliamp cells in a pack. But they are built in 8P configuration, 8P, not 3P, not 4P, not 5P. They went 8P or higher, because turned out that you need enough parallel connections to handle that load. Otherwise, it will not be dependable, especially for heavier person. No wonder. And turned out that this having high amp discharge, 30 amp, which means it stores that much energy in each cell, plus it's 4 amp hours, they both are almost unrelated to how the battery will perform when it's put to a load test. Being able to push the scooter and the person riding on it is a whole different story. Realize that you gotta have a physical extra, you gotta have enough physical number of battery cells in parallel to give you that power, to give you that torque, without voltage dropping so much. The greater the number of parallel connections you will have, the less voltage spike you will experience. The voltage will become more solid. It will be more steady, more consistent. It won't drop, spike so much. So I would recommend at least 7P. My next battery pack will be using the same cells, Samsung 40T cells. I will go full build in 16S 9P configuration, 9P, which is 3 times the size of this. That's what I'll be doing next time, if I can get the money somehow. I don't have the money to do it, which is why I went 3P. Because these battery cells are expensive. I don't have the money. If I had the money, I would have been able to build bigger battery pack. And I also wanted to test to see how it behaves with fewer number of parallel connections, and turned out that it's pretty bad. I would highly recommend that you go high number of parallel connections. More important than series connection. I guess that's about it. I will post more videos in the near future as new things come up. I will update and let you guys know. Show you the videos. I will be posting more and more videos of tutorials on building battery packs. All right.